Thanks a lot for inviting me to be here. I've been told that I have to bring it all together because I'm the Sciencepreneur. So I'm kind of gonna have to make sense of a lot of what we heard, and I actually got so many thoughts when you all spoke that probably would be worth discussing in the 50 minutes that we have. One is when you talk about like turning science around, academia around, kind of rolling it up kind of from the other side. I've been wondering, but then what happens to kind of the very important fundamental science? We need a place for that as well, right? CRISPR, for example, would not exist without, I don't know, 15 years of people looking into bacterial immune systems. But that was just a side note. And then I wanted to understand how many entrepreneurs are in the room. Please raise your hand if you're an entrepreneur. And if you're in academia and maybe planning to become an entrepreneur. That's way less than I thought. And then investors, corporates. Okay, very interesting. So very mixed. Okay. So I used to be a postdoc at ETH Zürich. I left ETH Zürich about 2 years ago. Yeah, founded my own startup. Now I'm co-founder and CEO and kind of CSO and CFO. And not quite. No, but I have the clicker, actually. It's all about coral reefs. Who has seen a coral reef before? Cool. And who knows that they are dying and they're in a really dire state? Perfect. So I won't have to go into that. You'll believe me, we don't have to go into why this is important. There's a lot of very tangible values that come from reefs, such as coastal protection, biodiversity, and everything that's connected to it, new products, new pharmaceuticals, and so on and so forth. But this is the reason why we rebuild coral reefs, and we've actually developed this system out of 3D printed clay, a modular system that we can reuse to rebuild a whole habitat. So a coral reef kind of from the scratch, from the ground up where they've been lost. So especially in areas where that three-dimensional structure has been lost, for example, due to dynamite fishing, which is true for a lot of the Southeast Asian reefs, for example. But also wherever the structure has been lost, which happens around the world. So we really want to rebuild a whole ecosystem. And I just want to bring you a little kind of look of you into a day in the field here. Last month we went back. We had built this reef a year ago, so we went back. We go back about twice a year. Last month we went back to check out on our reefs and take a lot of scientific data. How has it developed? Biodiversity, new corals settling down on the reef specifically. Maybe we can dim these lights a little bit. Nope. So it's the same reef that was on the last slide. We also installed, of course, I'm a scientist, so we installed lots of like new material tests where we want to improve this still, of course. Took DNA samples. It's a really good way of checking the overall biodiversity by looking at really the pool of genetic material that's present. Cool. And thank you. And if I say we're trying to rebuild a whole ecosystem, I mean, that sounds a little bit crazy, I guess, and also complicated. And that's because it is, and that's also the reason, I guess, why I'm here, and what we all kind of come from this complicated science, right? And have to somehow sell that and make sense of it. And when we started out, this is 2019 in the Caribbean, me and my co-founder Marie, and I'm trying to explain here to a couple of coral people our idea and our hypothesis of that we can rebuild reefs a lot better when we look at kind of the surface structure of what we're building with, because there's hydrodynamics and the surface will interact with the water flow, and there's always water flow, and coral larvae, corals are animals, and coral larvae are transported to a reef by the water flow. So we really have to understand how that works. And then people were more like, yeah, nah. And there's multiple reasons for that. The first reason is, in the coral community, about half of the people don't want you to intervene at all. They're all for conservation and protection. And everybody is in favor of that, of course, and we want to protect 30% of the whole ocean, ideally by 2030. But it also means that the reefs that are already lost and kind of look like this will never again, or probably never again, look like this. And we don't want that, right? We want more of these, and we don't want to lose 97% of them and not being able to rebuild them. And then the other half of the community is all for this kind of intervention and actively helping reefs, but they have, let's say, artificial reefs, so really putting new structure into the ocean hasn't worked for a very long time. One very bad idea were rubber tires. Like, rubber's just a very bad material, and it creates lots of micro rubber. And then other types of artificial reefs also just haven't worked because there wasn't enough thought, not enough disciplines came together to really think, well, kind of from a holistic standpoint, what do I need to rebuild an ecosystem, right? It's not simple. You can't just put something in the water, or like a bunch of cubes that are hollow instead of not hollow. Like, it'll create some more fisheries, but it won't recreate a reef. Yeah, and that brings me to my learning. And I put out some of these learnings because I thought there may be more scientists that want to become entrepreneurs. But one is certainly that we had to acknowledge we're doing something new and we'll need to convince people. And for us, this was a very important learning because in order to convince people, we decided to not do 3 more years of research, but instead just go with what we have and go straight to the field and say, okay, we need to build a showcase. We have to show people what we can do and actually test our hypotheses in the field straight away instead of kind of burying down in the lab. So we crowdfunded this reef. And the crowdfunding was probably the best thing we had ever done, because not only we got enough money to kind of finance us for half a year and build this reef in Colombia, 2021, but also a crowd that is having our back now. And now the coral community also likes us, and they're like, oh yeah, actually, maybe this is like the way to do it. You know, like, we need to rebuild reefs, and kind of now they're trusting in us because we showed something in the field instead of in the lab. And I think that's interesting that sometimes maybe applying stuff early on is, of course, a risk, but it can be very, very valuable. And we got the first baby coral settling down on the reef after about 8 months. Fish diversity went up much earlier. After about 3 months, you can see almost as high a diversity as on the natural reef. And now we could show, after 1 year, we have even more baby corals. They're very tiny. See, this is a centimeter. This is about the largest coral baby that we got. But we have 1 on every second brick, and per area of substrate, that's more than on the natural reef. So we were really lucky that we could show that actually a lot of our hypotheses did work. And brings me to a second learning, which is start applying the idea as early as possible and fail early. And I say fail early, and we were lucky that our hypothesis didn't fail. But I think it could have, it could have just as well not worked out and not be any corals or be too many algae on there. But this is something that I think as sciencepreneurs is maybe a little bit hard, and I would not have probably gotten there on my own. And I think very important here is that the co-founder that I started with, Marie, she's an artist. She has nothing to do with science at all. I met her at ETH, but she was there as an artist in residence. And it was only due to the diversity in thinking and in how we approach problems and make decisions that we were able to do this. Like she said, when we went to the Maldives, she said, yeah, Uli, I made these prototypes here, like the little ones that you saw. Let's just take them to the Maldives, put them in the water. I was like, no, Marie, no. Look, we haven't defined all the parameters for the surfaces. Like, we gotta know exactly what we're looking at, otherwise the experiment won't be perfect. She was like, yeah, but I made them already, and look, I just chose like 9 patterns that I liked, and now let's just take them. It's like, okay, but the results, they won't be as good as they could be. And so we just took them, and in the end, it was really a good idea because we got back results that the material worked. We got very high coral coverage on these. But anyways, not bore you with details, but diversity, I think, was key for us in starting. And having this, more the diversity really in how to take decisions. Marie's a doer, and I'm a thinker. I would otherwise have overthought everything. Diversity is key. So now we've survived for about 2 years, and I just said diversity is key, but we don't look diverse at all. I was talking about the mind earlier. Actually, we have a fourth person in the leadership team now, Josie. She looks the same. But you know, if you give me $1 million, or maybe not here in the room, but I would love to hire 6 more people and become a really diverse team. But what did I want to say? We've actually started. We've heard talks about where to get funding from earlier, right? For now, we got funding mainly from the crowdfunding, some from foundations, some private donations from companies, but and some like startup awards and so on. But now we've actually just decided that we're gonna start sell what we have. So now we're selling Reefs-as-a-service. And funny enough, there's a couple of values that you can get from rebuilding reefs. One is like mitigation of structures that have been lost, like when you build a harbor, you have to rebuild in the US, for example. We could do that. Or coastal protection, we're not quite there yet, need more R&D. For tourism, it's attractive, and because it creates biodiversity, because we've shown that that works. So now we're selling kind of biodiversity engagement to corporates. Any corporates, really, are interested in that because there's a beautiful story in it. When a company builds a reef with us or engages with us to rebuild a reef somewhere, they'll get kind of visual material from day one. They can take their employees, partners, customers on a journey, and you can see results happening very quickly, much quicker than, say, planting a tree, for example. You see fish swarming around us after 3 months. You see the new corals coming. The whole thing develops within a year, and it'll be grown by about 3 years. And this is something that they really like. It's tangible, and it's something that they can make a nice story from that's easy to share. So that's our way of trying to get funding at the moment. That's it. Compelling story is very important. And how many minutes do I have? None.
Seriously? -2.
There you go. Because I wanted to say something earlier about coming from the solution or coming from the, who said that earlier? Was it you? No, I don't remember. Yeah, right, coming from that as scientists often, of course, we're going a way of curiosity. So we're trying to find out, you know, the specific thing. What does this protein do? What does this bacterium do? Or this coral? And then maybe sometimes we think we found something and now we want to make a company out of it. But actually for me, it also started differently. I had been buried deep down in cyanobacteria and like tropical phytoplankton science. And then I just had the feeling after about 3 years of postdoc that it's not really the thing I wanted impact. I guess I wanted to get out of fundamental science in a way. And then I did this thing where I went to Silicon Valley to a thing called Singularity University. And there was a 3-month program and very diverse group, 47 countries, 90 people. So almost everybody was from somewhere else. And they brought us together to only think from the problem perspective. And that was very interesting. And I think actually Peter Diamandis, who's also a co-founder of the X-Prize, he led this program, inviting about 100 people that kind of, you know, smashed us with new ideas and mindsets. And this helped a lot turn some of the scientists that were there, and there wasn't actually that many scientists, but into entrepreneurs later. Because we were like, okay, we worked on these problems. We were like, what's the biggest problem in the ocean? I think it's the loss of coral reefs. And then started to do something. Okay, go on. Done.
Thank you very much. Allow me one act of cynicism. I think there's a reason why people like Peter Diamandis, X-Prize, Elon Musk, and all the other people are mentioned these places. And I wonder whether there's a consolidation going on that is perhaps not so healthy. A single way of thinking. But that's just me on the side. I'm going to allow one question and I'm going to ask it. Oh, no! Okay, you ask those questions. I'm just going to say, having heard that, how many of you want to drop your own ideas and go and work with Ulrike now? Yes. Well done.
How do you protect...
The sales position is very interesting. No.
It's summer holiday, isn't it? All year round.
How do you protect your coral reefs from the climate change?
It's something that we haven't figured out yet. So actually, rebuilding a reef at any given point in time is an emergency solution first, because about a quarter of all animals in the ocean rely on this structure and on the reef for survival, for food, and so on. So it's kind of rebuilding that habitat so that we don't lose everything, keeping the populations up. And then in the next step, what we do is we look with other companies and NGOs that work on making corals more resilient, so breeding corals. And then you could, in an easy approach, for example, dump a few million larvae over a new reef that come from resilient parents, and thus create a more resilient reef.
Thank you. Next, and I think last question, I'm going to keep.
Does this work anywhere on Earth in any kind of water?
No, only in waters where coral reefs would otherwise also thrive, so in the tropics and subtropics. Yeah.
That was a quick answer, quick question. One last one, down the back.
Hi. Who owns those places? Like, do you have to give a permission from the city or? Yeah.
Usually, well, if you work within 200 miles of a country, it's owned by the country. So we need a permission from the country. For example, the reef in Colombia will be owned by Colombia, which also means they carry all the risk once it's built. Whoa. But there's not really big risk. Come on, it's clay. Like, it's owned by the country. But when we sell it to a corporate, they basically get the biodiversity benefit, if you will. Right now, that's not units, but we're looking to create biodiversity credits, kind of an analogous to carbon credits. And they'll become mandatory at some point. But yeah, the reef structure itself will be owned by the country.
Brilliant stuff. Thank you so much, Ulrike. Right.